Let's start with section 3.1. You already have an idea about what the mean the tangent line problem. Remember, we have a curve, and we need to find the equations for the curve. So here's the tangent line. At any point, the tangent line is going to be here, which is touch the curve. Now, if we choose 2 points, and graph a line between these 2 points, this one is going to be the secant line. Now, at any point, so I'm going to choose the point C, and the y coordinate is going to be f to the c. For the other point, from the distance from this point to this point is going to be delta x, on the x coordinate. And from the x to this point, or from this point to the other point, is going to be delta y. And that's what we're going to find. So now we have a line. Our goal is to find the slope for this line. This is just the first step. We already know the slope formula is going to be y2 minus y1 over x2 minus x1, which is the slope for the secant line. Here's our secant line, and the tangent line is going to be here, which is delta y over delta x. Now, I have 2 points. This is the y coordinate. That's means x1, y1. And here's x2, y2. So to find the slope, we're going to plug in f to the c plus x2 minus, or y2 minus y1 over x2, which is here's x2, minus x1, which is the point C. So that's how we're going to find the slope. Now, we're going to find the slope for the secant line, but not the tangent line, which is here. So what we're going to do, here is the secant line. We found the slope for the secant line. If we took the limit, that's mean the secant line is going to go where? Closer to the tangent line. When the distance between these 2 points, that means if we choose a point here, here, the distance, where is gonna go? Closer to where? To the zero. So when the distance between these 2 points going closer to the zero, talking about delta x, the secant line going where? Closer to the tangent line. So that's why we're gonna take the limit for the slope with the secant line. That's what we're gonna use. If f is defined on open interval containing c, and if the limit for the difference between delta y over delta x, which is the limit for the slope, that means the limit when the distance going closer to the zero, that means the distance between these 2 points going closer to the zero, the secant line going closer to the tangent line. Okay? The slope, which is the limit for the slope. Here's our slope. Now, what we're going to call this one? Then the line passing through the point is the slope. But we're not going to call it slope anymore. We're going to call it derivative. Okay? So now, every time when they ask you, what's the meaning of a derivative? It's mean what? The slope, the same thing. The derivative, it's the same thing, the slope. The derivative, it's mean the same slope, okay? And we're gonna learn in section 3.2, the first rule, then the second rule, and keep going. Let's ask you an example 2. Find the slope of the tangent line. So where is the tangent line? So they already give you the function of the equation for the tangent line, which is g of x equals 6 over 5x plus 1. Now you already know how to find the slope, but you forgot. How are we gonna find the slope? Where is the slope? So we have a formula. It says y intercept form.
Plus B.
Which is y equal mx plus b. This is the y-intercept form. So that means g of x equal 6/5 x plus 1. So where is the slope?
This is 1.
That's it. That means the slope equal 6/5. Because they already give you the tangent problem, which is 6/5 x plus 1. What about next one? The limited process. You already have, this is the y-intercept form, okay? That means this is the slope, but this one is different. This is 3x squared. So on section 3.2, we're gonna learn an easy way to find the slope, which is the first derivative. But now we have to use the limited process. The limited process, let's do it here. Now our function, which is, I'm gonna try to solve everything here. Our function is f of x equal 3x squared minus 4.
Mr. K, we still can't see what whatever you're writing.
Okay, give me one. Okay, now we're gonna use the limited process. So the second step, we're gonna say, okay, f to the x plus delta x equal. That means instead of each x, you're gonna plug in what? X plus. Instead of each x, you're gonna plug in x plus delta x. That means here is going to be 3 x plus delta x squared minus 4. Who has a problem now? Is that okay? I'm using the rule, the limited process. You will see on the examples, they're gonna tell you use the limit process to find the tangent line problem. The limited process, that's mean we're gonna use the rule on the board, okay? Now here's f of x, and here's f of x plus delta x. So I'm gonna use the rule. It says the derivative, which is the slope for the x, is going to be the limit when delta x approach to 0. The rule says f to the x plus delta x minus f to the x divided by delta x. So this is the rule. Okay, that's how we're gonna find the slope. I'm gonna plug in, here is fx plus delta x. F of x, I already have f of x, and here is delta x. That's mean the slope, which is now we're gonna call the derivative. It's the limit when delta x approach to the 0. F of x plus delta x is going to be 3x plus delta x squared minus 4. What else? Minus f of x, which is the function here, 3x squared minus 4. And everything divided by delta x. Now here's the thing. If you take the limits now, that means you're gonna say, I'm gonna plug in delta x equals 0, and the result is going to be undefined. So what you have to do, when the result is undefined, what you have to do, you have to simplify. So let's check, can we simplify here? That's mean f of x equal the limit delta x approach to the 0. always our goal before we start plugging to cancel the delta x. Can I simplify here? It's a 3. Foil this one, which is x. X plus delta x, it's x plus delta x times x plus delta x. Yes or no?
Yes.
So when you FOIL it, going to be x squared plus x delta x plus also x delta x plus delta x squared. These are the same terms. So it's going to be x squared plus 2x delta x plus delta x squared. I'm going to plug in everything here. Yeah, so it'll be x squared plus 2x delta x plus delta x squared. And now minus 4. I'll distribute this sign. So minus 3x squared plus 4. Everything divided by delta x. I'm telling you, it's a longer process, but do you feel it's hard? Have to practice on it. F prime to the x is going to be equal the limit delta x approach to the 0. Gonna distribute the 3 here. So it's going to be 3x squared plus 6x delta x plus 3 delta x squared. Here is minus 4 minus 3x squared plus 4. Everything divided by delta x. Now check, do we have like terms? Can we cancel this one with this one? Cancel the 4 with the 4. You see what's the left? The left 2 terms contains delta x. Delta x, delta x. Next step is going to be the slope equal is the limit delta x approach to 0. 6x plus delta x delta x. 6x delta x plus b delta x and divide by delta x. That's mean the limit when delta x approach to 0. What I'm gonna do here? Do I have common?
No.
Delta x, delta x. Delta x means delta x squared. Don't confuse yourself. It's not just delta because there is no sign, there's no variable delta.
So you can cancel out 1 delta.
Yeah, that's mean I'm gonna take delta x as a common. You can take the 3 also. But then our goal is to cancel the delta x. So delta x, the left here is going to be 6x plus 3 delta x.
Oh, I see what you mean.
You got it?
Yeah.
Divide by delta x. Cancel these. That's me. Our slope is going to be the limit delta x approach to the 0, 6x plus 3 delta x. Now, if limit, now we're gonna plug in the limit. If delta x goes to the 0, this part is going to be what?
Undefined. Wait.
No, it's gonna be 0. You're gonna plug in 0 here, 3 times 0. It's going to be 0. So what's the left? 6x. That's mean our slope for the tangent line problem is going to be
6x.
6x. I think that's the only thing they ask you to find. Or find the equation.
No, this is
No,
slow.
that's it.
Just a slope?
Yeah.
How do you know it's the slope for the whole curve? When they ask you find the slope for this function at this point. We found the slope for the whole curve for the tangent line, okay? We need to find the slope at which point? At this point. So this is the x and here's the y. That's mean the slope at the point 2, 8 is going to be 6 times how much the x? So it's going to be 18.
Well,
Only 12 here.
Wow. Okay. The slope for the whole curve is going to be 6x. But at this point, 2, 8, the slope is going to be 12. I think I get a different number.
Mhm.
Find the slope for f of x equal -6 by using the limit process. Okay, that's mean we're gonna use the same rule here. Now I'm gonna ask you, f of x equal what? -6. What about f to the x plus delta x equal what? If you check the previous example, we're just gonna plug in instead of each x, you're gonna plug in x plus delta x. So if your function, for example, is 2x, to find fx plus delta x is going to be plug in instead of each x, plug in the whole thing. That means it's going to be 2x plus delta x, okay? Now, what about if you have f of x is -6? What's that mean? -6 is what? Come on.
Your y.
Which is the y, which is constant function. So when you graph it, it's going to be a line like this. 1, 2, 3, 4, 5, 6, -6 is going to be a line here. It's a constant function, okay? On -6. That's mean f of x is -6. What about if you said f of x plus delta x? Do you have an x here? No. Can you see an x here?
No.
That means it's going to be the same number, -6. Okay? So to find the limit process of the slope, what's the slope of constant function? 0. So when you're taking the limit, delta x approach to the 0, which is f of x plus delta x minus f of x divided by delta x. Here's the rule. That's mean the slope is going to be the limit and delta x approach to the 0, -6 minus 6 minus -6 divided by delta x. The whole thing here is 0. 0 divided by delta x, that's me. That's it. Can we do the same thing? So I have f of x equal x squared plus x minus 2. What about f to the x plus delta x? It's going to be equal what? It's going to be x plus delta x squared plus x plus delta x minus 2. Yes or no? Now, it's up to you. You want to simplify first, or you want to just go ahead and plug in? Both is going to be right. You want to simplify this part first? Because I have here two parentheses, which is x plus delta x times x plus delta x plus x plus delta x minus 2. I'm going to simplify this part before going to plug in, okay? It's going to be the same thing. That means it's going to be x squared plus x delta x plus x delta x plus delta x squared plus x plus delta x minus 2. Let's this one. X squared plus 2x delta x plus delta x squared plus x plus delta x minus 2. This is not x. Yeah. X plus delta x minus 2. Okay. Now we're going to use the limit to find the derivative of this law. It's going to be the limit delta x approach to the 0 f of x plus delta x minus f of x divided by the x. Questions? And then plug in. This is the rule. Come on, no. This is the rule, okay?
Okay.
You lost? Let's write down the rule. Now I'm going to plug in. So f prime to the x is going to be the limit when delta x approach to the 0. F x plus delta x, which is this one, is going to be, we're going to plug in the whole thing here. That means it's going to be x squared plus 2x delta x plus delta x squared plus x plus delta x minus 2. We finish?
No.
Only this part is going to be the whole thing here. Minus what? F of x, which is our function. So it's going to be x squared plus x minus 2. So it's up to you. You want to simplify it fast, or you want to plug in, go ahead. Both is going to be right. But be careful. I prefer you simplify this part first, then go ahead and plug in. So you're not going to do mistakes. This, so we can. So next step, we'll do the next step here. That means f of x is going to be the limit when delta x approach to the 0. Can you tell me this one? Delta x squared plus 2x delta x. What? Delta x squared
Plus x.
plus x
Plus delta x.
plus delta x
Minus 2.
minus 2. Distribute the negative sign. Distribute the negative sign. Okay. So it's going to be negative x squared minus x plus 2. Everything divided by delta x. Check. Our goal is to keep the terms with the delta x. That means this one is going to cancel with this one. Yes or no? What else? X, negative x, this one, and this one. You see, if you still have a number or a term without x, without delta x, that means you have something wrong. Because you see the left, delta x, delta x, delta x. Now, the slope is going to be the limit delta x approach to 0 2x delta x plus delta x squared plus delta x. Everything divided by delta x. It's going to be the limit. Delta x approach to the 0. Take delta x as a common. What's the left? 2x plus delta x plus 1. Yes or no? And be careful. Delta x squared is the same thing, delta x squared. Delta x squared, not just the x. Okay? That's why we took one out, the left here is delta x. Cancel these. That means our slope of the derivative when delta x approach to the 0, 2x plus delta x plus 1. Now, if you plug in delta x to the 0, that means this one is going to be 0. What's the left? 2x plus 1. So that means this is the limit, this is the derivative of the slope of the whole curve. If they ask you at a certain point, you have to plug in the point, okay? To find the equation of any tangent line, always we're going to use, it's a tangent line. Remember this formula to find the equation of any line, y minus y1 equal the slope x minus x1. We're going to use the same formula to find the equation of the line. Or you can say y equal mx plus b. So the same thing. I'm always using this one. What we need to find the equations, we have a point. So we have y1 and we have x1. We need to find
The slope.
the slope. The way to find the slope, we're going to use the limited process. On the next section, we're not going to use the limited process. We're going to use the rule, okay? So it's going to be smaller step. So now we're going to do the same thing. We're going to find the slope first, which is the derivative, by using the limited process. Then we're going to plug in to find the equation of the tangent line. So now, f of x equal the square root of x minus 1. What about if you have f to the x plus delta x equal what? You're gonna plug in, instead of each x, you're gonna plug in what? X plus delta x. So it's gonna be square root of x plus delta x minus 1. Is that hard? Now we're gonna plug in the slope, which is the derivative, equal the limit when delta x approaches to 0, f to the x plus delta x minus f of x, and everything divided by delta x. This is the rule. Can we plug in? In f of x, f of a prime of x, which is the derivative, the limit, delta x approach to the 0, fx plus delta x is going to be square root of x plus delta x minus 1 minus f of the x, which is the square root x minus 1, and everything divided by delta x. Now, the next step. How are we going to simplify this? By the conjugate, you forget that? No. You're going to multiply by what? By the conjugate for this part, which is the square root of x plus delta x minus 1 plus square root of x minus 1 over, you're not going to multiply on the top part, you have to multiply the bottom part with the same thing. Minus 1 plus square root of x minus 1. You see the same thing, but different sign in the middle. Okay? Let's do another step before we jump into that step. Check here. On the bottom part, I'm not gonna do anything. I'm just gonna write delta x and put the whole thing with parentheses. Because we don't have to distribute, just keep the whole thing with parentheses and delta x on the side. That's mean f prime to the x is going to be the limit. Delta x approach to the 0. You see, I had the solution. In the notes, the solution exists, but I'm trying to solve it by myself. I have the solution. In the notes, you can check the notes, you can find the same steps. But always you have the steps, go ahead, solve it by yourself. When you're stuck on certain step, go ahead, check, where's the mistakes? Now I'm gonna write down the bottom part, I said the same thing. This is gonna say, here's delta x. And I'm gonna say x plus delta x minus 1 plus square root of x plus x minus. I'm not gonna do anything with the bottom part. Now let's multiply this one. That's the important thing.
That's gonna be x plus delta x minus 1.
Okay, because we multiply radical with radical, it's gonna cancel. So it's gonna be x plus delta x minus 1. Multiply this one,
Same thing. Right.
no,
Negative.
plus, no, I'm talking about this one times this one. So you're gonna type the radical,
Oh, okay.
x plus delta x minus 1 times x minus 1. You know what I'm doing? I'm distributing this one times this one. It's going to be here. Now, this one times the second one is going to be here. Now we're gonna go to the next one. Now we're gonna multiply this one times this one times this one. You got it? So the next one is going to be minus square root of x minus 1 times square root of x plus delta x minus 1. Yes or no? The last part is going to be minus x plus 1. Be careful here. Not the plus 1. When you multiply these two, the radical cancel the radical. Negative times positive is going to be negative. The radical times this radical is going to be x minus 1, put it in parentheses, because the negative sign is going to distribute.
Will we cancel out?
Yes,
Okay.
so these cancel. Let's see what they got. So what's the left? Left, let's be f prime to the x of the limit. When delta x approach to the 0, what's the left? X plus delta x plus 1. Yes or no? And no, minus 1. A minus 1 and minus x minus 1. You see on the bottom part, we didn't do anything. Just keep it like x square root of x plus delta x minus 1. Plus or minus? Plus. Square root of x minus 1. What's the next step?
Distribute negative.
Yes. to the x is going to equal the limit delta x approach to the 0, x plus delta x minus 1, distribute the negative sign, is negative x plus 1. Divide by delta x plus delta x minus 1 plus x minus 1. Cancel. What's the left? What's the left? On the left, is that delta x? Can you cancel with this one?
One.
No, it's 1. Going to be limit. Delta x approach to 0. 1 over plus. Now take the limit. If you plug in the limit 0, what's the left here? Going to be x minus
-1.
x minus 1. That's mean f of x is going to be, I'm going to take the limit now, so you don't have to write down the limit anymore. 1 over going to be x minus 1 plus x minus 1, which is equal. Can we add these together?
1/2 times square root of x minus 1.
So doing 1 over 2 square root of x minus 1. That's mean this is just the slope. Now tell me the slope at this point. At the point when x equal, at the point 10(3), because we didn't finish. That means x equal, how much x?
10.
You're gonna plug in 10 here. So it'll give you 1 over 2 square root of 10 minus 1. 10 minus 1, 9. Square root of 9, 3. 3 times 2. So the slope at this point is 1/6. The slope at all the points on the curve equal this one, okay? Now we have to go back to this formula to find the equations of the tangent line, which is y minus y1 equal the slope x minus x1. So y minus y1 is 3 equal the slope is 1/6 x minus 10. Now we just have to simplify. This is the right solution. Just simplify. Y minus 3 equal 1/6 x minus 10 over 6. Add 3. That's mean y is going to be 1/6 x minus 10 over 6 plus 3. Can I write down 3 over 1? Times by 2 to get, no, times by 6. The y is going to be 1/6 x minus 10 over 6 plus 18 over 6. That means y is going to be 1 over 6 x plus 8 over 6. Can you simplify this one? 1 over 6x plus 4 over 3. So this is the equations of the tangent line at this point. Okay? You see, the whole thing is to find what? The whole steps we did just to find the slope. What they ask you, find an equations of the line that is tangent to the graph. Here is the graph. And parallel to the line, there is the line. Now we have a graph and we have a line. The first note, graph and a line. Okay, we can find, do we have a point?
That's the line.
We don't have a point because the line, like which point you're gonna use? Because the graph is tangent to a line parallel to this line. So which point? That's the main thing. Which point is tangent to this graph? That's what we're gonna find. But we're gonna find an equations of the line. Like just imagine that it's a simple graph. Here is your curve, okay? We need to find an equations for the line that is tangent to the graph. Here is your graph. Let's say here's the point. This is the tangent line, okay? That's what we need to find. But this line is parallel to which line? To the line 2x
Y plus
minus y plus 1. This line is parallel to this line, okay? We need to find, you see the tangent line here to the graph? That's our goal. When we start, I'm gonna take this line here on the side. I'm gonna say 2x minus y plus 1 equals 0. Okay? Now, can I rewrite this one to
Yeah.
find the slope? The slope for this line.
Y minus 2x minus.
Okay, that's mean you're gonna move the y to the other side. You're just gonna add y to both sides. So it's going to be 2x plus 1 equal y, which is the same thing, y equal 2x plus 1. Yes or no? That's mean the slope equal? The slope equal?
Yep.
The slope, I'm not gonna get confused. This is the slope. I'm gonna say this is the slope for the line, which is equal to. What's the next step? I don't have a point. My goal is to find this point. Okay? Now, I'm going to find the slope for the graph. Okay? By using the limited process, which is the slope for the tangent line. I'm gonna find the slope for the tangent line to the graph. How I'm gonna find that? Because it's a tangent to the graph, so I have to use the limit process. So f of x equal x squared. Until now, I don't have a point. That's my goal is to find the point. F of x plus delta x equal x plus delta x squared. Yes or no? Can I simplify this one?
Yes.
I'm just gonna simplify it right away. You have to write down two parentheses and distribute it. So it's gonna be x squared plus 2x delta x plus delta x squared. Okay? Any questions so far? Use the limited process to find the slope for the tangent line. So our slope is going to be the limit when delta x approach to the 0, f of x plus delta x minus f of x divided by delta x. That means the slope of x is going to be delta x approach to the 0 is going to be x squared plus 2x delta x plus delta x squared over delta x minus what? I'm gonna simplify it. And so these two, So what's the left here? F of prime to the x is going to be the limit. Delta x approach to the 0. 2x delta x. I'm gonna take delta x out. The left is 2x plus delta x. Everything divided by delta x. You lost or no? Yes or no? What's the left here? Cancel this one with this one. The left is 2x delta x plus delta x squared. Take delta x as a common. The left is 2x plus delta x. So that's what we have here. Cancel these two. Take the limit. How much is going to be? Take the limit. That's mean plug in 0 here. The left is 2x. That means the slope of the tangent line is what? Let's say this is m to the tangent line equal 2x. Yes or no? Do you have a point now? What do we have? What do we have?
We have the slope to the curve and the slope to.
When you have two parallel lines, the slope for the first line is going to be equal to the slope for the second line. When you have two lines, when you have two parallel lines, the slope for the first line is going to be equal to the slope for the second line. So we have two lines parallel. That's how the symbol. Let's say line parallel to the tangent line. That's mean the slope for the tangent line is going to be equal the slope for the line. That's cool. That's mean the slope 2x is going to be equal what? 2x equal what? 2. Solve this one. How much is going to be x? 2x equal 2. That's mean x is going to be equal 1. Now we have the x. How are we going to find the y?
Squared.
Y equal x squared. You're going to plug in y here to x to find the y. That's mean f of an x f of an x equal x squared.
1.
So f of an x is going to be 1 squared. That's mean y is going to be equal. Do we have a point now? Yes or no? We need to find what?
1, 1.
We need to find this line. We have the slope for the tangent line, which is equal 2x. That's mean it's 2. We have the slope, we have the point. Can we find the equations?
Would we use the same one?
The slope for the tangent line is 2x. And we have the point xy equal 1, 1. That's mean our slope for the tangent line is going to be 2 times 1 and equal 2. Now we're going to go back here and say y minus y1 equal slope x minus x1. Y minus y1 is 1 equal the slope is 2 x minus 1. So y minus 1 equal 2x minus 2. That means y is going to be equal 2x minus. You got it? Now the same thing, exactly the same example. If they change this word to perpendicular. The only thing here, they change it. What's gonna happen to the graph? The same graph is not accurate, but I'm just showing you. So here's our curve. Here's the tangent line. Okay? Our goal is to find the tangent line for the curve. Exactly the same example. The previous one, I'm just changing the word parallel to perpendicular. That's mean, here's the line.
Intersect.
Perpendicular on this one, okay? What's gonna change? The thing is gonna change. They're gonna give you the line here. The slope, let's say this is the line L, and here is our tangent line. The difference is going to be that slope for the line is going to be 1 minus 1, -1 over the slope for the tangent line. Okay? That's the only difference. The slope is going to be -1 over the slope for the tangent line because it's going to be perpendicular. You're not gonna get example like this, but I'm just showing you what's the difference. If there are two parallel lines, the slope is going to be equal, okay? If there are perpendicular lines, the slope is going to be for the line -1 over the slope for the tangent line. Or you can do the opposite thing. That's right, if you say the slope of the tangent line is -1 over the slope of the line. Both is going to be right. Okay?